Hello, water managers. My name is Andy Richter, part of the Water Management Systems Division at the Hydrologic Engineering Center. I'm going to be covering HEC-RAS for SWMS today. This presentation is part of a series of recordings that will cover various topics relating to HEC-RAS modeling for SWMS. There are 6 main topics that will be presented in this series. Previous videos have covered the first 5 topics. This video will cover real-time forecasting using HEC-RAS. So let's get started. When running a forecast in SWMS, these are the steps you will generally follow. First, you must check incoming data to ensure that any required inputs to your models are available and look reasonable. The next step is to run all models within your forecast that precedes HEC-RAS, which may be HEC-METView, HEC-HMS, and HEC-RES-SIM. The model outputs should be checked and the models calibrated until you are happy with the results before moving forward. Next, you will run HEC-RAS, review the results, calibrate if the model outputs do not match observed data, and generate depth grids if they are needed. The most important and often most overlooked portion of running HEC-RAS inside of a SWMS forecast is the calibration process. The first step in this process is running the HEC-RAS model alternative. You should always review the model results and compare them with observed data to ensure that your model is performing adequately and providing data that is reasonable. If the model results do not match up with observed data, you should begin adjusting model parameters and repeating the process of running the model and comparing results with observed data until the two converge. So how do you compare model results to observed data? HEC-RAS provides many ways to view results, but there are a few that you should focus on when running a SWMS forecast. The first place you should look is at the stage and flow hydrographs at specific locations with gauges that provide observed data. These plots will help you identify what parameter adjustments are needed within the model to get a better fit between computed results and observed data. Another important place to look is at the profile plots for each of your model reaches. HEC-RAS will plot observed data at points within your reach, but the most important thing you should be looking for are anomalies, spikes or dips within the water surface profiles. Any anomalies indicate that the model is not producing reasonable results, and all efforts should be taken to adjust the model until those anomalies disappear. So there are several ways to adjust model parameters within the HEC-RAS model when calibrating. One way is to open the geometry and begin adjusting Manning's end values or ineffective flow areas at each cross-section. This is how models are developed and initially calibrated, but this is not an efficient way to calibrate when running a SWMS forecast. Instead, we recommend setting up flow roughness factors inside of your plan files. This is similar to the approach in HEC-HMS that uses zones to calibrate the model. This option allows you to adjust roughness coefficients with changes in flow. This feature is very useful for calibrating an unsteady flow model for flows that range from low to high. Roughness generally decreases with increases in flow and depth, and this is especially true on large river systems. This feature allows you to adjust the roughness coefficients up or down in order to get a better match of observed data. By viewing hydrograph plots, as we reviewed on the previous slide, you can determine which roughness factors to adjust depending on how the model is reacting at various flow rates. We recommend that you check and fully calibrate your model by adjusting base values instead of the roughness factors at least once a year, especially if the factors start diverging. So now that you have calibrated your model, you should perform one last check to validate your results, especially if you need to create an inundation map. So pay special attention to locations within your model that may cause instabilities, such as bridges, junctions, inline structures, and steep reaches. As noted previously, reviewing the profile plots for all of the reaches in the model will help identify any locations that need adjustment. If you see spikes in the water surface profile, as shown in the plot on the screen, you should review the model at those locations and adjust parameters until those spikes are eliminated. You should also review the runtime messages for any warnings or errors. This can help you determine locations within the model that need further refinement. So now that we have calibrated our models, we're ready to develop an inundation map. So right-clicking on the stored depth grid within HEC-RAS Mapper allows you to generate the map and save it to disk. So one thing I want to stress is the importance of not generating the saved map without checking the results first. We recommend not checking the box next to floodplain mapping within the unsteady flow plan, so that you are required to create the map manually from HEC-RAS Mapper. This will get you into the habit of reviewing results prior to creating the inundation map. If you have any other questions about our software, need some help, or are looking for additional training, check out these links. They can also be found in the description below. Thank you for your time.